Hello, welcome you all. Myself MP Mishra, Faculty, School of Computer and Information Sciences, IGNOU. I am with you in this session on a topic, types of database management system. If you remember in your previous session, we have discussed about what is database, what are advantages of database and how a database help different kind of business application to be developed. In this session, we will try to know that what are the different types of database management system and what are the advantages of those database management systems. And before I come to actual discussion of different type of database management system, let me try to know one thing, that what actually a database system does. It decides that how data is going to be stored, and second, it uses some kind of approaches to search the data and answer the query or a specific query related to the data stored in the database. On the basis of these two parameters, that how data is stored and how searching process is being performed on the data stored in the database, decide the different type of database management systems. Now, if we talk about the different database management system in terms of the time taken in responding the specific query, on the basis of that how the response time is related to a specific query or how the data is saved in the memory, database management system can be seen basically of 4 types. Though there are several other types of database management system, but our concern is related to these 4 basic database management system types, and these basic database management system types will provide us awareness about the database management system uses and its application. So, on the basis of the storage and the searching, we can categorize database management system in 4 categories. One is the sequential or the flat file structure, second hierarchical database management system, third network database management system, and the fourth relational database management system. There are many other also like object oriented database management system, some image processing database management system, maybe some text storage database management system. So, on the very specific requirement, there are different type of database management system also, but we are basically concerned with storing of the record. As I mentioned that in the form of table we have created some record, and those particular records are stored and they are being used for the processing of different activities. Then for that purpose, these 4 categories will help us to understand about the database management system. I am continuing in this discussion with relation to the previous discussion also, in which I have shown you a table, and in that table you were having multiple records, and those things we tried to see that how table is created and how different records are identified. Further, if we try to categorize the database management system in terms of the number of users who are using that particular specific database, for example, maybe the single user database or multiple user databases, and the storage of the database, whether it is centralized or distributed, whether the database is a journal purpose database or it is for the some specific purpose. So, these all are different type of approaches which may lead to different type of databases, but our main concern is to know that how actually the things are stored and how actually data processing is happening in that. So, if we talk about the sequential file or sequential database, then we can say that it is a simple file structure in which we are storing the information, and the searching in this particular structure will be sequentially. Means you have to search the information from beginning to end to find the information if it is stored somewhere in between. It is not that directly you can go into any specific information and retrieve that. That is why it takes lot of time and it is having more time consuming process during the query operations performed on that particular database. So, this kind of database can be used for very basic operations or some general purpose operations like keeping some financial details of your day to day activity or keeping some information related to working activities of the weekly plan or some simple office records like basic attendance or something like that. But if you are having some complex information and in that you need a kind of processing where you have to perform different kind of searching of the data and updating of the data, then this particular sequential file structure is not suitable. For example, if we take one example that we are going to manage the shopping information and we are doing the shopping again and again for our purpose of livelihood or requirement of livelihood, then we may store the different kind of items which we are going to shop, the description of the item, maybe the price, maybe the quantity which has been purchased, shop name, address of the shop, maybe the date of purchase, the amount paid or maybe the amount balance. These all things are the routinely happening activities and that is stored by the individual user, and for that particular the sequential file structure may be used. But if you look on this particular information little more closely, then you will find that this is not a very structured information. It is the information is a kind of raw information which is coming and directly just you are storing that particular information without having a proper structure of management of that information. So, proper structuring is missing in such kind of storage planning, and it lead to redundancy also, that it may be the repeated information is stored several times or repeatedly. So, to avoid that, different kind of data structures or the structure used for storing the data, and they make the different kind of database management system. Before we move to hierarchical network and relational database management system, let me try to again revisit what we have discussed in our previous session about some common terminology which is generally used in database management system, like attribute, which talks about the columns in the table, then records or tuples, which talks about the row in the table, and similarly the relation, the different attributes related to each other, or maybe how one table is related to another table also, and some keys and constraints like some rules under which the table is created and data is inserted in the table or maintained in the table. So, these few basic concepts are essential for us to know, to understand the different database management system which we are going to discuss further in this session. Let me try to visualize the keys and constraint in little more depth or with the help of one example. While we are designing a database or while we are designing some mechanism to store the data which is generated for our application or which is to be managed for the specific application, then we can say that it is nothing but combination of different attributes which are making the specific table. So, all the attributes in a specific table are related to each other, but you try to find out one specific attribute that is known as key attribute or primary key, which can be used to identify the each record in the table. So, that particular is a key constraint. It means you are having provision of one key, on the basis of that particular key or the key attribute or specific column, you can identify the specific row. For example, if we are going to, let us say, create a database student or a table student, then in that we will be having a key attribute, that is the enrollment number of the student. So, every student must have that enrollment number, and second, what will be, the enrollment number must not be empty field. It means the enrollment number should be some value, it will not be null. So, another constraints you can apply, that is not null in the case of your attribute or the column is being used for the identification purpose, or it belong to primary key, or it is a primary key. So, in that case not null constraint should be there. It means the value of the primary key should not be null. Similarly, referential constraints, as we are discussing that in a specific database there may be several tables and there are possibility that several tables will be related to each other, then on what basis they will be related to each other, that is also a question to think about. And if we think about that, we will find that there are some common attribute between those different tables. On the basis of those common attribute, there is a linkage, and that linkage provide connection between the tables. That connection is used for the purpose of referring one table from another table, that is called referential constraints. It means when we are referring from one table to another table, we should be sure that data is available in another table when we are going to do some kind of operation. So, that is called referential constraints. It means in the case of referential constraints where we are going to refer, let us say, from one table to another table. So, that particular second table in which we are going to refer is having the specific value for which we are looking for. If we talk about a hierarchical database model or hierarchical database system, then here we are having a hierarchy in the form of storage. For example, there will be some information at the root, and this root will be having some childs. So, those childs will be having some information, and those childs will be having relation to the root. Similarly, childs also will be having their own children, and they will be related with their own parent on the top level. So, you are having a hierarchy from top to the bottom, and in the root you are having one node that is controlling all the things, or that is the base of all the connectivity, and that is known as root or the base point of the discussion. And that root may be your specific entity or table which is there, and that particular table is being used for the purpose of providing relationship to the different child table, and similarly maybe other child tables are also having their own child table and they are connected. So, in that way hierarchy is there. Now, in this process if you are searching, let us say, from the root, then you are now not going to search sequentially. From the root if you are searching, you know whether the data belong to its left child or right child, then on the basis of that either you will go to left or you will go to right. Similarly, at the child level, if data is not available, again you will decide that whether it is left child or right child. On the basis of that you will move for the searching. So, here searching is very fast compared to sequential one, and data storage is also properly managed. It is simple to construct because we are using very basic simple concept of the hierarchy which we generally apply everywhere in our daily life or routine activities, and this type of database is generally used in normal business operations or daily life activities. Accessing data is faster because it is having hierarchical. So, you are cutting lot of information in single search, and then you are concentrating towards the area where your actual data is probably available. Now, next comes the network data model or network database model. This particular database talks about the parent-child relationship, but here one child can have many parents, and the records or the data stored uses the linked list data structure to store the information. So, in this we are making much more complex because now the structure is little bit more complex, and it is having much more relationship or many more relationship from one particular entity to another entity, because here it is allowed to have more than one parent to a specific child. So, it means from one particular node there are several nodes which are connected or having relationship. Now, further if we talk about, so we can say that network database management system use the network structure to create network relationship or a kind of relationship between the entities. What actually entity mean, that we will be discussing in detail in the next session, but entity here you can visualize anything which is being used for the purpose of storing the specific related information. For example, employee may be an entity. If you are having a table for employee, so you can say that particular table is representing employee entity. Similarly, in this particular model, as we discussed, that it is having provision to have connectivity of more than one child to a parent, one child may have more than one parent. So, it is basically making a kind of more complex system, and in that particular system you can say that there is a several relationship existing between entities. For example, if one parent is having more than one child, so in that case you will find that complexity is much more. Network database also can be seen on the similar ground of the hierarchical database, but unlike hierarchical database, it is having more relationship or multiple parents. This is the main difference between these two. And as far as storing and searching operation is concerned, obviously it is much faster than the sequential one. And advantage of this particular model is that it eliminates unnecessary duplicate information, because it is providing multiple kind of connections. So, for every connection you don't need to keep the data separately, because one particular node may have relation with multiple node at the hierarchy in the topper level or the higher level. So, if higher level hierarchy node is having connection to a, let us say, one entity, then that particular entity may be connected to different higher level entities in the hierarchy, and in this way the redundancy of the data is minimized. In the network model, we can say that the relationship between entities can be seen m to n. It means if there are m entities at the one level in the hierarchy, there may be another n entities, so they are connected with each other. So, in that way the complexity of the network model or network database is more, but it provides lot of advantage in terms of storage of the data. So, it will be minimizing the duplicacy, as well as it will be providing much faster access of the information, or searching will be less time consuming. Now, next model is the relational database model, which is generally used for many of the application or majority of the application which we generally see around us. So, this particular model is based on a very basic concept that is known as the finite set and its relation concept. And relational scheme or relational concept basically talks about the relation between the entities, and this particular model uses a concept of two-dimensional table, and that particular two-dimensional table is called a relation. And in that two-dimensional table, what we are having? We are having some columns and then some rows. Rows are basically representing the record stored, and columns are representing the different relations on the basis of that particular database or the table is created. So, columns are representing the characteristic of that particular table or that particular entity for which the table is created, and individual row is representing the individual entity for which the information is stored. It means there are several entities of the similar type for which the information is stored in a specific table, and that particular is being represented as a kind of relation. So, rows are representing, again I am repeating, the record, and that record means one entity, and column is representing the specific characteristics of all the records of that particular table. Now, some basic advantages of this particular database model is that it is very popular, and most of the application use this particular type of database. It has various integrity rules which ensure consistency, like the primary key, not null, referential integrity. All these rules are properly applicable or properly applied in this particular type of database system. Easy to use and handle, it means it provides facility to manage the relation as well as per the requirement, the relation, the kind of requirement or structure of the table that can be managed or can be changed. And one more thing here we should know, that if we are talking about a relation, then to represent relation, one concept is used that is known as degree of relation. So, degree of relation is basically the number of attributes in that particular specific table. For example, if we are having a table employee, and in that particular table if we are having 5 columns, then degree of that particular relation employee will be 5. So, the number of columns in a table define degree of that particular relation for which that particular table is created. So, in this model data is stored in 2-dimensional, because this 2-dimensional is something very common which is used and it can be easily shared and it is properly representable also, and this particular 2-dimensional representation of the data or management of the data basically suits to the concept of the set theory, and from there the basic working principle of the set theory are applied, and on the basis of that the data is stored in the table or in the relation is managed. Relational database model uses the concept of relational mathematics, that is the sets and relations, to perform the operation or to provide the services. And to perform different kind of services in the relational database management system, one very popular query language, that is structured query language, is used. This language help in managing different kind of information of the database, that includes inserting, updating, deleting and searching of the records. So, basically in any setup or any kind of operation, these will be the basic requirement of working on that particular database. That is, if you need to insert some data, you can insert. If you need to update some specific value of a specific record, you can update. If you want to delete the specific record available, you can delete. And similarly, if you want to search specific information, whether it is available in that particular table or not, you can search it. For example, again we can talk about a normal example of, let us say, for the shopping related example where the customer is going to purchase some product. So, obviously customer will be a kind of relationship in which the information related to different customers can be stored. So, customer table will be created. Similarly, products, there will be different products available in the store and those products table can be created. Similarly, supplier again will be having different kind of information associated with the suppliers, that may be the supplier ID, supplier name, address and the different related information. And similarly, another table may be the order. Order means the product has been identified by the customer and they have make the order. So, order related maybe the payment is also associated. So, all these things if you visualize in a normal shopping scenario, you will find there are different tables which exist to perform the operations of the data which are being used in this particular processing, and how actually this whole system will make the data management properly if we are making different table to represent different related operations or related activities by making different tables. In summary, in this session we can say that whenever we are talking about database management system, we have to think about that how actually the data is stored and how fast the searching process is. And in a nutshell, at the beginning or at the elementary level, we should also understand that there are different type of database available, and generally those can be categorized in 4: the sequential, the hierarchical, the network and the relational. But most commonly used database system is the relational, in which the data is stored in the form of a 2-dimensional table, which is represented in the form of columns and rows. Columns represent the attribute and rows represent the records. And to manage or to perform the operation, one specific language is used, that is the structured query language in the relational database tables, and by using that particular language different kind of operation, whether insertion, deletion, updation or modification of the database table or the content of it is there, those things can be done. So, with this I conclude this session. We will meet again in next session. Thank you.